Welcome, technical session number 37. We're going to be getting into maintaining Windows environment. Our objectives for this particular technical session are going to be to identify common preventative maintenance and updates necessary to keep Windows running smoothly. We're going to be describing how to perform the maintenance updates using the appropriate command line, administrative tools, and system utilities. If you dive into this a little bit more, and name which command line, administrative tools, or system utility to use for a given update or preventative maintenance check. We're also going to be trying to identify some common pitfalls that can occur when performing maintenance checks, updates, and how to solve them. PSMs to keep in mind for this particular session to be customer focused, because without customers, we don't have a job. So we need to make sure that their needs take primacy in our actions. Obviously, we would not want to exceed our mandate from our organization, but do what we can to help them out in the situations that they're in. Also, personal responsibility. We say we're going to do something, we do it. And then the flip side of that coin is if we did something awesome, say it. Advocate for yourself. Doesn't necessarily mean you have to be arrogant about it. Just say, hey, last quarter, sales are up 25%. That's me. All right. So, maintenance overview. So, best practices, preventative maintenance is more than just manipulating hardware. It's also encompassing running software utilities on a regular basis to keep the system fit. So many of us neglect this. If it runs, we don't think about it, But a computer, much like a car, if it runs and you don't do anything to kind of keep it running, eventually what happens? It breaks down, right? So we have to try to keep the tools up to date and running so that it can be running at peak performance and allows for less wear and tear on our systems. So some of these utilities we would utilize would be scheduled backups, check disks, defragmentation, and updates. Obviously, we wouldn't do defragmentation on solid state drives, but mechanical drives are still pretty prominently used in the market, especially in desktops. All right, so why do we do this? Keep our system file structure error-free. Prolong our computer life because, who wants to just throw money out the window? Not me, not any company. And we want these to be running at peak performance as long as possible. And then it also alleviates slow performance, which is frustrating to pretty much everybody involved. So, what are some things we can do? We're going to talk about scheduled backups, and there are different types of backups that we can use, and we do need to know the difference between these. Disk maintenance, regular updates. At the time of this technical session's writing, they were still optional, but optional is not really a thing anymore. It's not a matter of if you do the updates, it's a matter of when you do the updates. Then we have patch management, driver and firmware updates, and then anti-malware and antivirus protection updates as well. All right, backups. So we have to make sure that we have a redundant copy of all the information that we have in some way, shape, or form. That way, if something catastrophic happens, we don't lose everything. Not only do we have to have backups in place, but we have to test these backups to make sure they're actually happening and that the backups are valid. So we have to have a mechanism in place to go back and test, our redundant backups on a regular basis just to make sure that the system is functioning properly. I knew somebody who worked for a global company that their home office or headquarters was in Dallas, Texas. And if you guys remember, was it 2 winters ago where they had that really, really bad ice storm? Pipes froze and burst and all that kind of fun stuff. Well, one thing is they had their server room in the basement. Typically not a bad thing, but they had their servers on the floor. They didn't have their servers on raised racks. So they had their servers close to the floor. Pipes burst in their building, flooded their basement, destroyed, I think it was like 2/3 of their servers. And this is a global company. Operates in more than 50 countries. And they were like, oh man, we got to replace the servers and we got to get the backups. So they replace the servers and they go to get the backups and there are no backups. They had scheduled backups and it was supposed to be doing backups, but the backups were not transmitting. And nobody was actually testing these backups. So this was a large global company. All I can say is they were linked to the Department of Defense. But they were able to rebuild a lot of their infrastructure through the local servers they used, but they still lost a significant amount of data. And so probably tens of millions, if not 100 million in losses, all because somebody was not testing the revenue or testing the backups. So it's not enough to set up the schedule. We have to test and make sure these things are happening. So we have types of storage that we can use. We have on-site, which is our local. This would be like on your hard drive. We have, or an external drive that you use. There could be a local network server in the building that would run backups as well. And then we have off-site storage, which is cloud. And typically you would want, if you had a company that operated in more than one location, you would want backups in more than one location, especially, consider like you live in Florida, this is where your headquarters is, but you have offices in Chicago, Atlanta, New York, LA, Dallas, and all that fun stuff. And they're all up and running, but you're just like, you know what? Save money. I'm just going to keep my servers here in Jacksonville. And then a hurricane hits. What do? You're now down across the board because of an event in a single area. Have to have redundancies in place. Every single geographic location has its weather events, whether it be blizzards, mudslides, hurricanes, earthquakes, tornadoes, what have you. These events occur. So we have to have contingencies in place. So that's something to consider when you are doing on-site and off-site backups. All right, so we have 3 different types of backups that we really need to bear in mind. And then there's also what they call working copies or shadow copies. And these are partial or full backups that are kept on the site just for like an immediate backup. This is like a tertiary backup. So the 3 types of backups we need to keep in mind are our full backup, which is pretty straightforward. It is what it says it is. It's a backup of everything. And then we have an incremental backup, which only backs up information that has changed since the last incremental or full backup. And then we have a differential backup, which is the changes that have been put in place since the last full backup. Can anybody think about why we would want multiple different types of backups? What would be one very big reason why we would have different types?
If one goes down, you have the other.
It's a possibility.
If one has a virus or malware, you can take the specific parts.
Okay. Well, I'm talking about like 3 different types of backups. I have a full, an incremental, and differential. Why would I have 3 different types?
Because of the timing it takes to back up.
Perfect, Savvy. Because of the time it takes to do these things. Running a full backup on all of your systems can take hours. Do we want to take hours out of our business every single day? No, right? So you're going to create essentially a backup schedule. So let's do
Back to the house.
Monday. All right, cool. So Sunday, typically most businesses' slowest days, especially like Sunday evening, tends to be the slowest time for any type of business. So this is typically when you would perform your full backup because system usage is low. You're not really disrupting a lot of business. You can take the time to do this. So you perform your full backup on Sunday night. Now, of the 2, incremental and differential, incremental is also the quicker of the 2. So this is the fastest. So on Monday, you would do an incremental, which would just be the stuff that changed since you did the full, right? Tuesday, do another incremental, which would get everything you've changed since Monday. Wednesday, we would get a differential, which gets us everything back to Sunday. And then we would do incremental, 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 full. So the key here is knowing, 1, what the 3 do, and 2, what drives do we need if the system goes down? So if my system goes down on Thursday, what drives do I need to restore my systems?
You could do a differential.
Okay, so I need this one, right? Is that all I need?
Then probably the 2 incrementals as well.
So we think we need the incrementals. Is that it?
Okay, then it'll fall as well.
There we go. Because remember, the incremental change is only what changed between, since the last full. But here's the thing, the differential gets everything that changed since the last full. So incremental since the last full are incremental, differential since the last full. So we actually negate the need for these 2. We would just need the differential and the full. And that's all we need to be able to restore ourselves up until today. Does that kind of make sense? So once you hit the differential, it negates the needs for these 2. These 2 can be overwritten at that point. So if I lost my drive on Tuesday, what drives do I need to recover?
Monday and Sunday.
Monday and Sunday, right? So I need these 2 drives to get up and running. Very good. What if I lost my drive on Friday? What do I need?
Wednesday and Sunday.
So Wednesday and Sunday
And Thursday?
and Thursday. There we go. Because we have the full, the differential that gets us everything back to the full, and then the incremental that gets us everything since our last differential, right? So Sunday, Wednesday, Thursday. Does this kind of make sense? And what we're doing is we're creating a system of backups that's going to keep us as close to up to date as possible while creating minimal downtime for our systems. So we're only really doing the full backups once a week because they take a long time and they use up a lot of system processing power. So that's why we'd utilize things like the full, incremental, and differential. Please take a screenshot of this, understand the differences between these backups because it does come up. All right. So schedule backups. You can use in Windows, you can use Windows System Protection. And you can use that to automatically backup system files and store them in regular intervals at a predetermined location. It could be like at home, you could use an external hard drive, you could use a NAS, something like that, or you can use a cloud service. Same thing for business. We would also create restore points, which takes a snapshot in time of our system files, but it does not include our user files. So you can set up your restore points to be taken at least every 24 hours. And it's also a great tool for, fixing a device. If there was an issue with software or an update, something along those lines, you can always roll back the process using restore points.
Can you just repeat? You said snapshots, they make restore points of system files, not user files?
Yes. So it would take a snapshot of all the applications and their settings and the files within those applications. It would not take a snapshot of your documents, spreadsheets, and stuff like that you have saved. So that's something different. So you need a backup for that, not a restore point. So system restore is dealing with system files, and then you would create a backup for your documents and stuff like that. So all right. Disk magnets. Some of this stuff we've already gone over before on a pretty regular basis. So this is just kind of a review. We want to check our hard drive and see if errors have occurred or bad sectors have, come up. It happens. So on Windows-based machines, we use something called scan disk and check disk, which are command line utilities to check for bad clusters in our drives. But they also have GUI tools for error checking. Mac has a disk utility, and Linux uses file system checker. In the event they discover bad clusters, they basically flag them so that data cannot be written to them, and it tries to recover data from them as quickly as possible, if at all possible. So, file system checker and, or excuse me, check disk and yeah, file system checker. All right, here's kind of what it looks like in the disk maintenance, where you can go in, check for option or check for errors, and you can try to repair those errors in, if you wish, and try to recover data from the bad sectors if at all possible. All right, defrag. We talked about this a little bit leading up to here. Again, only done on mechanical drives. And what it's doing is it's taking all the data and putting them in clusters next to each other. So all my Excel file data is going to be together. All my Word file data is going to be together. All my Candy Crush high scores are going to be together. They're not going to be scattered all over the place because the computer was putting it in any available space that was, ready to be written on. So it's going to have to essentially rewrite the entire drive so that all what they call contiguous sectors, or things that are alike, are next to each other so that it's easy to read the information. All right. When you're doing defragmentation, the arm of the drive, it's going to be very noisy. It's going to be writing and rewriting, and it's going to be thrashing the drive. So it's going to be reading and writing a lot. So you're going to hear a ton of activity while defragmenting the drive. But this should decrease the amount of activity you hear after this maintenance is done. And things should move a lot faster. If you perform this maintenance on a regular basis, like once a week or something like that, you can keep your system running at peak performance. If you are a system admin and you were setting this up for your users, this is something you would schedule to be done at night, like 8, 9 o'clock at night, as a regular maintenance thing, to go ahead and defrag the drives and keep them running smoothly.
Every night?
Not every night, but I would say like at least once a week or something like that. But you would want it done at night, not during the day when the employee is trying to do work, because it's going to slow the system down significantly. So if you wait like once a month, once a quarter, the defragmentation process can take hours to do. If you have mechanical drives at home and you have not performed this maintenance task, you might want to try it, see if it, kind of makes things run a little smoother. Please don't do it during class. Wait until set it to start working when you're getting ready to go do something else for the day. Like if you're going to go eat dinner or whatever, whenever you're kind of stepping away from the system, then you would run something like this, because it's going to slow things down. All right. Here's a look at the disk defragmenter. If you have multiple drives, you can select it to run on just one particular drive at a time. Or if you have a solid state and 2 mechanicals, you can make sure not to run it on the solid state, so you don't risk damaging the drive. It even says never run. So that'd be one all right. Disk cleanup. So this basically gets rid of different types of files to try to free up space on your hard drive. One is going to be your recycle bin. So we're going to have to clear out those deleted files, but also, before you do that, make sure there's nothing in there that you absolutely need. Some of us delete things on accident all the time. Temporary internet files, cache files, downloaded program files. When we download a program to install in our system, it keeps the installer program on file for some reason. This will clear that out. Temporary files. So it'll delete all of those, and then it's going to go through, it's going to check for errors, make sure the disk, health is okay. It's going to compress folders, ones that are probably rarely used. It's going to move files and folders to other drives if need be, delete unneeded files occasionally. And we need to remember that our hard drive needs to be at least minimum 15% free space. Otherwise, it is going to seriously slow down your system. So if you're exceeding 80% on your hard drive, it's time to start looking at either deleting a bunch of stuff or looking at getting a new hard drive.
Kelly,
Yo,
if we add a second disk and extend the volume and then perform a disk cleanup, will it still take as long?
it may take longer if you add if you're adding additional space for it to check and verify.
I mean, like in regards of like, if our disk already has 80% used, and then we like
Oh,
we know,
are you saying it'll stop, stop operating so slowly?
no, I mean like when you perform a disk cleanup
Mm-hmm.
on that extended volume that spans across both disks,
Mm-hmm.
like would that like make the time? Would that make your computer run slow still, being that one disk is still
Yes,
control?
it would, because again, it's using processing power and reading and writing power. And so
Mhm.
unless you have the saved data distributed across those two drives, you're not going to get the speed benefit of using two drives.
Okay.
So if you add a volume and you span it across, you're still having to do all this work on this one drive and then spill over to the next drive. If you're doing something like a RAID, just for the sake of argument, a RAID 0, you can have two drives working simultaneously, and that would cut the time down. Does that make more sense?
Yeah.
Now, what may be happening if it's moving files from one to another to kind of free up space on a singular drive, it could be moving files from the heavily filled drive to the empty volume that you just spanned to in order to create those efficiencies, but it wouldn't happen the first time. That would be something that would happen over time. All right, disk cleanup. We just talked about this. This is kind of what it looks like. Open your Windows Explorer, right click on the volume that Windows is installed on, and select properties. Once you get to properties, you can go to disk cleanup in the general tab. And then if you want to take a look at the files that are going to be deleted in the temporary, you can click the cleanup files, and then it usually will give you a list and say, hey, do you want to delete all these? Then you can unselect ones that you don't want to delete, and then go from there. And then if more space is needed from there, you can go to more options and see what else can possibly delete it. It'll start looking for what they call duplicate files, which is kind of a mixed bag. Sometimes like our resumes, we may have 4, 5, 6 copies of a resume. It may view these as duplicate files and start deleting the various copies that you have. Or you may have copies for a specific reason. So you have to be careful about this. But it'll give you other options to kind of help free up space as you need. So another good one to run on a regular basis. All right, Windows Update. I know here it says keyword here, optional. It's no longer optional. It's just a matter of when you do the updates, not, if you do the updates. It used to be if you wanted to, you did. So you have different types of fixes. You have updates, service packs, and then you'll have hot fixes, which are meant to serve specific issues. The updates are individual fixes that come fairly often. And then a service pack is usually a large update, which is like it could be like a newer version of the operating system. So if you have like 10.1.3, and then the next service pack you get is 10.1.4. So it's a much larger update with more features and bug fixes and all that kind of fun stuff. So that's what they mean when they say service pack versus an update. An update is more of a targeted fix of a particular application or service. So if you're overly trusting of Windows and you just say like, sure, just send them on in every time, we'll take it, update it right away. You can set it to do that, or you can have it on a delay where you can wait and see if the updates are going to affect your systems. If you have homegrown applications and things like that, you typically are going to have it on a delay so that you can do a sandbox test to see how it affects everything else you're going to use. You test it, and then if it works out fine, it runs basic tests, then you go ahead and deploy it to your systems. Trying to think here. That's about it for now. So we had that all the time at our company where they would say, do not run updates. We're trying to work patches in so that it does not affect our systems. If you run the update, you know, our intermodal system would no longer work. So we would have to delay for 3 months, 6 months, stuff like that. Here's the problem though. Vulnerabilities come out in an update or a hotfix and something like that, or a service pack, it becomes a race against time. Because once these vulnerabilities are known and set up like this, it's also advertising that this is a vulnerability, you know, to bad actors that may have not known that they were out there. And so they will start trying to attack these vulnerabilities on known systems, hoping they can get to them before the updates are applied. So it's not something we can delay inevitably, but it's just something else we need to consider. All right, patch management. So this is basically the process of keeping the software up to date, safe, all that kind of fun stuff. They're trying to help fix bugs, but as patches come in, we as IT professionals need to have our sandbox ready. We will run the update on our various machines. Like we said, you may have a virtual machine of every different type of setup you have in your organization. You have images created for this. You would deploy those images in your system, run these updates on these images, and see if the patches have any negative effect on your system. So you would have a series of things you would test, verify, make sure everything works, and then deploy it. So doesn't seem like it's that important, but what if it's a hospital? You know, what if the servers go down in a hospital? How important do we think that's going to be? Pretty heavy, right? So depending on your industry, this is going to be more and more critical, and they're going to be less and less tolerant of any kind of misstep. So good practices help keep things up and running and ensure minimal, if any, downtime.
So a patch and an update are essentially the same thing, right?
Yeah. Well, I mean, it's different types of updates. So you have like, yeah, a patch is like an update essentially. But it could be a hot fix for a particular vulnerability. Yes, Emilio.
Patches, would you say, I guess, a smaller like band-aid than an update? Or
Well,
There's
updates
not.
themselves are going to be smaller regardless.
right.
So what they're saying is patch management. So it's managing updates as they're coming in and hot fixes.
Yeah, okay.
So it could be a specific vulnerability. It could be updating just a specific program. or whatnot, but the way computers work, if I update, if I run an update on Candy Crush, it could affect my Excel just because it's, the changing of code. You flip one switch here, it affects things over here. So, we have to test these things just to make sure. All right, driver firmware updates, all the fun peripherals that add such wonderful functionality to our systems regularly have to be updated so that they can continue to interact with our systems, because we're updating our systems. The patches may not continue to work, so we have to update those patches. These are much smaller software files than the standard updates that we would do, but they need to be kept up to date because there may be vulnerabilities discovered, there may be added features that they can give us, all that kind of fun stuff. It may be that it needs additional information to be able to interact with the new operating systems that are coming out. So, these are things that we need to stay on top of and maintain. Also, firmware, our ROM chips, for our BIOS and all that stuff. They do not get updated all the time, but they do come out on occasion. And when they do, we got to take care of it. Because there's usually security fixes, additional functions, all that kind of fun stuff. We need to check it for functionality. And what do we call it when we're updating our BIOS? What is that called?
Flash the BIOS.
Flashing the BIOS. What happens if something goes wrong when we're doing it?
It's brick.
Bricked.
Very
Paperweight.
expensive paperweight, yeah.
Yes. Big frowny face. So, like I said, when techs are doing firmware updates on very expensive machinery, you'll see them get extremely paranoid. They'll have multiple power supplies hooked up to them, two UPS devices, and then plugged into different breakers. I mean, it gets paranoid, how they do this, because you don't want to have a slight power hiccup and lose a $20,000 server. All right. Antivirus and malware updates. So, generally speaking, most people, when they think of any type of malicious program that is going to infect their system or do something to their system, they refer to it as a virus. This is kind of like calling a hard drive memory. We understand what they're saying, but it's not an accurate statement. So later on today, we're going to talk about different types of viruses and stuff like that. So we'll be getting into it a little bit. But anti-malware is a host of different types of malicious software, where a virus is a very specific thing. Now, antiviruses can work in two different ways. They work in what's called an active seek and destroy mode, where they're working off of what's called signature lists. Basically, every virus that comes out has a particular code signature, and we would have a definitions list or signature list that has all of these signatures in it. It would look for that particular code in various programs that we use on a day-to-day basis. If a program comes in or has something along that, it's going to kill that program. That's the active seek and destroy. Then you have passive sentry mode, where it's kind of looking for unknown things. So it may not have a signature on every virus that is out there, because tens of thousands are discovered every day. So this is something we have to kind of keep up to date on a regular basis. So they may operate off of what's called a heuristic algorithm. And basically that is just a really fancy way of saying behavior. So what it's looking for is certain types of things going wrong. High traffic or activity in certain programs, unusual spikes in memory usage. So it's going to be looking for certain types of behavior that are going to be conducive with a piece of malware or a virus or something along those lines. And if it sees that, it's going to quarantine that system and alert you to it. All right. But we're going to get more into this afternoon. Right here, backups. They have the older systems. I'll have to look up and see what they do for Windows 10 and 11. You can do a backup through Control Panel for Windows Vista. On Windows 7, you right click on the drive and you select Properties 8.1, File History tool, and you can set up a drive to back up everything too. System Restore, that's in the Control Panel and pretty much everything. And then the System Protection tab. Recovery image, you can either use a recovery disk or CD, although most people would opt for a USB. Or you can create a partition on your drive that can be accessed after post. My general recommendation is to use like a USB or something along those lines, because if the drive is damaged, then you can't recover from that partition. Check disk lets you display the properties of the hard drive and check for any kind of errors on the drive itself. Defrag, we already went over that, putting all contiguous sectors together. Command lines. I know you guys are excited about this stuff.
I thought I got away from it.
Thought you did. And yet you showed up to class. And then there's more. But so we're getting into these in Coursera. We're also getting into these in into Linux and all that kind of fun stuff. They're similar, but there are some differences in dialect, so to speak. So task kill is a utility used to terminate processes. And we can identify it through its PID number, which is its process ID, which we can figure out in Task Manager if we wish. And then the process can be isolated in command line, and we can do task kill / we can do PID, or we can do the actual program itself if we wish. There's task list, which is kind of like using Task Manager in the actual GUI form, and this will give us all the running tasks that we have going at the moment. If we were trying to run this on a remote machine, we would hit the /S, and then we can designate it for another system that's running. Then you have the rexec, which is a way to authenticate us on a remote PC and let us run commands on that PC. All right. Shutdown is what it says it is. So it basically just turns the computer off. We can use various switches or arguments with it. So we can do the shutdown /S, which would just turn the computer off, /R restarts it, and /M lets us specify a computer other than this one. And then there's the boot rec one, which is a way for us to kind of fix boot sector or boot record errors or damaged sectors or what have you. So this was the command that got me during my exam, because I could not remember it for the life of me. So you have the argument of fix boot, which would go fix, any boot sector issues. You have MBR, fix MBR, which would fix any of the new or fix any master boot record issues. Or you could do rebuild BCD, or scan OS, and that would scan all disks, for installations of the boot manager, all that kind of fun stuff. So this is one I would say, please remember, because it did come up on my exam when we had a damaged boot record and it had to be fixed. So I had to do the bootbrec/fix MBR, and this was a simulation, not a multiple choice. So that is definitely one I would write down. I don't know if they still do that one. But that was the one that got me. I was only able to get partial credit on that one. Yeah, let's not try the shutdown command answer. All right, other command tools have come up, but good ones to use on a regular basis. EMD to make directory, RD to remove directory or delete directory. Talking is hard. Delete directory. CD to change directory. DEL to remove files. Copy to make a copy of a file. Then Xcopy, which is the extension of copy. So it'll copy the directories as well as the files within those directories. Go ahead and take a screenshot of this one if you have not. These will come up again. At the very least, we need to know how to use or pick these out of a lineup and know what they do and whether they associate with Linux or Windows. But don't worry, we have a study tool to help with that. All right, robocopy, which is short for robust copy. And it keeps the NTFS permissions in the copying process. Dispart gets us into the partition applet in command line, where we can set up partitions, extend, shrink volumes, span them, whatever we wish to do. GPU updates. We did this in test out like a week or so ago. And GP results, so we can see what was updated. We have live practice with this one, thankfully. If you forget, please redo the labs, because the labs help build that muscle memory. System info gives detailed information overview is what's going on with your system, what kind of processor you have. You have virtual memory, how big is it? Basically, all the detailed information about your system. Check disk, gone over that one a couple times. Look for errors. SFC, or system file checker, scans all the system files, comparing them to the original versions and see if anything was altered, deleted, mismatched, or changed, and then replaces them with the original file. And you can either do scan now, which will do it right that moment, scan once, which I think does it the very next time you boot, and then scan boot. Can't remember. You remember what scan boot does, Rach? Is it every time you boot, or is it just
I
one
can't
time?
remember.
I'll have to double check that one. Apologies. dir, that is your directory. It's like your ls command in Linux. Go. Other administrative tools. Such as like the administrative tool folder, computer management, Microsoft Management Console, and various snap-ins that you can include in your system depending on the version that you have. So we have the Windows Defender Firewall, where we can set up our ACLs. And if you have advanced security, you can set it up on not only your system, but remote systems as well. Windows Memory Diagnostic checks to see if your RAM is functioning properly, because eventually these things break down. Print Management manages your printers, print servers on the network, and then you can perform administrative tasks as well, like resetting the spooler, deleting print jobs, all that kind of fun stuff. Local security policy allows you to view and edit group policy security settings. And then component services lets you configure and administer your COM components. And those are typically used by developers and administrators. I know it seems like a list, but it's basically what a lot of this is. We will be getting into a lot of these as we go through, like when we're dealing with security and stuff like that. So we'll talk about a little bit more of these. And yes, we need to know each of these things, what their basic function is. Performance monitor, used to examine how the programs are running and how they're affecting the overall performance of the computer. And this can be used for real-time analyzing and collecting log info to view later if you wish. Task manager shows all open tasks, allows you to kill them in that process if you wish. Task scheduler lets us set up things to run during non-peak times, like defragmenting the hard drive, running anti-malware scans, all that kind of fun stuff that's going to be processor heavy that we don't necessarily want to do while somebody else is using the system during peak operational hours. Okay, so it is what I thought it was. Scan boot will do that. We'll run the scan every single time you boot your computer. Thank you, Rachel. So scan once, we'll do it the next time you reboot. Scan boot, we'll do it every time you boot. All right, event viewer. This is where all of our logs are kept. Just a reminder, everything we do, everything we open, everything we change on a computer is kept in a log. An event viewer is where we would go to search through these logs and see what happened shortly before things started going, bad for our systems. Shared folders, this is where we would, set up files that we can share with coworkers or family members or what have you. Device manager, all the peripherals that are hooked to our system, from monitors to speakers to microphones to NIC cards, RAM modules, all that kind of fun stuff. It allows us to perform updates on them, all that kind of fun stuff. Disk management helps us manage partitions. We can set up RAID arrays, all that fun stuff from one fun little application. And then sysconfig, also known as msconfig, allows us to edit and troubleshoot the operating system and program startup processes. Anybody ever gone through and look at your startup files and see all the fun stuff that starts up every time you launch your computer? And you realize that every little applet that you downloaded for, a week that you used one time is all being started up every time you start your computer? Like, why do I need TurboTax to start up every time I start my computer year round when I only use it once a year? Steam is pretty bad. Dropbox is horrible.
Can I just say that the event viewer is your friend when it comes to troubleshooting?
Yes,
We'll use that a lot.
you are absolutely correct. So if something crashes, you can go back and look at it, all that kind of fun stuff, and it'll tell you what was happening right before that. So very, very true, Rachel.
Kelly,
Yes.
could you go back 2 slides really quick?
Oh, man.
Oh, 3 slides, sorry. One more.
That's an extra click. All right, here we go. So system
you.
file checker, scan now, means you want to do it right then. Scan once, we'll do it upon reboot. Scan boot, we'll do it every time you boot.
Okay.
Spotify, that's another good one, Brandon. All right, so task managers, what it kind of looks like here. You can look at the individual applications that are running. You can look at your CPU usage, like the performance, your CPU, usage history, memory usage, which is your RAM, all that kind of fun stuff. And you can see what's actively being used there. Then you can go into your applications or processes and services and see what is using up the majority of those resources. Do you have a rogue program? Do you have a piece of malware that's causing problems? All that kind of fun stuff needs to be considered. All right, so sysconfig utility, open your start menu, type msconfig. Once it comes up, you can start it up, ready to go. Then you can go to your startup tabs and start looking through and seeing what is causing you problems. Here's kind of what it looks like. Then you can uncheck anything that you don't want firing up every time you start your computer. I highly encourage you, if you've never done this, to go through and look and see what's being started up every time you start your computer and see if there are programs that are launching that you never use. But here's the caveat. If you don't recognize it, look it up before you turn it off. But if you see it's something like Dropbox and like, oh my gosh, I used Dropbox one time because I had to download it to get a file from a coworker, and I haven't used it since, but it's firing up and using up memory every single time you launch your computer. Turn it off. And or uninstall it, get rid of it if you don't use it on a regular basis. It's just using up space. Don't be a digital hoarder. I know you paid 99 cents for that app 6 years ago. It's time to let it go. Minecraft Mobile. There you go. If you're still playing it, keep it. But if you're not, let it go. Minesweeper Ultimate Edition. Does the app spark joy? Yeah, that is a good question to ask. What was her name? I forgot the lady's name. The organization lady. Does it bring you joy? If it doesn't bring you joy, get it out of your life. Condo, there you go. Thank you. Yes, Emilio.
Yeah, so I went took me to the task manager, and for like the startup, and it just says there's like a I guess a column. It just says startup impacts, and it says not measured on some.
Yeah, then you're going to need to go into your msconfig to actually look and see what everything is getting started up.
Oh, okay, msconfig.
Yeah,
Gotcha.
so msconfig is where you're going to actually be able to turn those things on and off, whereas task manager is going to kind of tell you, is there a major impact or not?
All right.
So it's like using these tools in conjunction. The problem with that lady's method, though, Justin, is if you're a hoarder, all of those items spark joy, and it sparks fear when you get rid of them. So it's kind of a misfire on that. I get where she's coming. All right. Go. Fun little video. First, I gotta share sound. Otherwise, only I will get the joy of it.
By far, a scheduled backup is one of the most important maintenance tasks that you can configure on your computer. It's very common to configure these to perform once a day, once a week, and in some cases, once an hour. You need to configure what you'd like to back up. Maybe it's every file that's on your computer, maybe just the files that have been changed, or maybe you'd like to do an entire image of the computer. That way, if you need to completely rebuild this from scratch, you've got an exact duplicate of everything that was on that system. Sometimes you can provide these backups on site, but of course, there are a number of off-site options as well. In Windows, for example, you have OneDrive that's in the cloud that can take all of your documents and not only store them locally on your computer, but also store a copy out in the cloud.
Fire backup's so important.
Hey Kelly, I'm not able to see that page on my screen.
What was that, Chris?
Okay. I'm not able to see the assignment on my screen. I don't know if it's because I clicked the link, the nearby link.
You're probably watching mine versus clicking the link.
No, I actually clicked the link, but I clicked it from Slack.
That's student pace. It's different. So here's the one in that we're on right now, which is the instructor led. So there's two different links.
Okay, gotcha. Okay, thanks.
So as not to lose important data, have access to your files if something goes wrong. Keep all your data accounted for.
We're usually storing all of our files in some type of permanent storage device on our computer, so it's important that that device always be working perfectly. We want to avoid any types of hardware failures or warning signs that we might be losing our storage device. One built-in capability on these storage devices is called SMART. SMART stands for Self-Monitoring, Analysis, and Reporting Technology. You can use third-party utilities to look at the SMART statistics on your drive to see how it may be performing over time. Another thing you can do inside of Windows is to perform both a logical and a physical check of the drive. The logical check will look at the file system and make sure that all of the files appear to be in order, and the physical disk check will go through every sector of the drive and make sure that we're able to read and write from all parts of the drive itself. If you're using a traditional hard drive with spinning platters, then you may want to take advantage of the built-in defragmentation function inside of Windows. Whenever we're storing files on our hard drive, parts of the file are stored in different places on the drive. So in order to read that file, we now have to revisit all of those different sections of the drive to put the file back together. If we're able to defragment that drive, we can take all of those different pieces and put them into one contiguous piece. That way, we only have to go to one place on the drive to read the file, which means it will have a much more efficient read and write performance. Obviously, if you're using an SSD, which is all solid-state memory, then you won't need to perform a defragmentation. You can start the defragmentation in the Windows user interface by going into the properties of a local drive, and you will see an optimize and defragment drive option there. At the command line, you can simply type defrag to perform a defragmentation. You might also want to set up a schedule to perform the defragmentation. You can do this directly from the Optimize Drive dialog under Scheduled Optimization, or you can go to the Control Panel under Administrative Tools and change this in the Task Scheduler.
Yep, it should have about more than 20% free space, just to make sure the system can function and write properly.
Another important best practice for maintenance of your computer is to always keep the operating system up to date. And we do this under the Windows Update section inside the control panel. This is going to provide you with security patches for the operating system. It may provide new features of the OS. And if there's any updates to drivers, this may resolve problems you might have with interfacing with the hardware on your computer. You can configure the Windows Update to happen all automatically, so all the files are downloaded automatically and installed automatically. If you'd like a little more control, you may choose to only download the files, or to maybe only notify you that files are available to be downloaded. Or you can disable this completely, and it will be up to you to manually set up the update process for your computer.
All right, we cannot disable updates. Instead, we can only postpone.
In environments with many computers, you may not want to have every device automatically install all of the updates. You may want to instead have a well thought out patch management process. This allows you to manage the update process because occasionally you run across an update that either doesn't work properly on your computer or it may break a feature of the applications that are important for you to use. And there are so many different operating system patches, application updates, driver updates that you want to be sure you know exactly what's being installed on everyone's workstation. So you may want to set up a process where you're testing, you're scheduling the deployment of these updates internally. You finally can implement and make sure they're running properly. And you may want to have a fallback option as well in case something doesn't go well during the deployment. The device drivers that interface our operating system with our hardware aren't often updated, but when they are, they can resolve nagging problems that we might have interfacing with our hardware components. You may see some device drivers updated more than others. For example, it's very common to see video drivers updated very often. Some drivers are updated automatically through the normal Windows update process. So if you have Windows Update set to perform all of these updates automatically, you don't even have to think about it. But you may have to manually download some of these drivers that aren't managed through Windows Update. You can always look at device driver to see exactly what drivers are installed, and you can drill down on these to find out more information about the specific driver that's configured in your Windows operating system.
All right, see. Possible loss of functionality. Vulnerabilities could be hackers could take advantage of it. Loss of data. Systems get corrupted. All sorts of fun stuff.
An important maintenance and security update is for your antivirus and your anti-malware software. The bad guys are constantly coming up with new ways to get into our systems, so we want to be sure we have the latest signatures installed on our computer. This will be signatures for your antivirus, your anti-spyware, anti-malware, and any of the other security components that are running in your operating system. You may want to set this up to occur every day, or if this is a very important system, you may want to have it happen every hour. This may be a process that's even automatically configured now, and you don't even have to think about it. Your system will always have the latest signatures installed in the operating system.
In general, things are always changing. New viruses are always coming out. And if we're not keeping up to date, our system becomes exceptionally vulnerable to this. Oop. Oh. Oh, was it just my bad. All right, some pitfalls we run into. Automatic updates. Programs can stop working. They don't interact well with others. Hardware stops working. We may have to boot back into safe mode, roll back the updates, or roll back the drivers, whatever is causing those issues. Whatever we just changed, likely causing issues with other stuff. Power loss during firmware installation. Say a mea culpa. Buy a new motherboard and hope you don't do that again. Not installing the correct version. Replace the computer. All right, backups not completing, hangs on error messages, saying disk is full, all that fun stuff. Follow the help dialog and try to resolve the issues through the troubleshooting software, and or you may just need a bit. But other than that, we should now have a little bit better understanding of some preventative maintenance tools and updates that we would utilize on a day-to-day basis. Have a kind of a fun list of ones. that we need to be aware of. We should be a little bit more aware of how to perform some of these maintenance updates, as we have been doing some of them in test out for a couple weeks now, as well as Coursera. Got a little bit more into command line stuff, because I know you guys were clamoring for more commands. You're like, we don't have enough on our plate already. Please give us more. And so, we brought the goods. And then finally, talk about a few brief common pitfalls when doing some maintenance checks and updates, and how we should solve them. Although the BIOS firmware, it's like, oops, error. Okay, replace the computer. That one seems a little extreme, but unfortunately is the case. Might be hardware, but motherboard itself is toast. Questions, comments, concerns, complaints, revolutions? Am I interfering with nap time? We need to do like Zoom charades. I will call Avery in here. He loves doing things like that. I will just turn him loose on the whole class. It'll be a torturous afternoon. All right.
They don't know. They don't know.
We don't want to know.
He is an overly positive person. He's a great counterbalance to my gloom and doom when I talk about security. But sometimes it's a little bit too much rainbows and sunshine. He's a really good guy though. All right, so we're gonna open up the rooms one more time. What day are we on in Canvas?
29.
29. Where are we in Coursera?
Course 3, module 3.
Course 3, module 3. You're on it, technically. All right. I'm going to open up breakout rooms. Rachel, can you grab Joseph and just kind of show him where we're supposed to be at in course, like the email? We can just go over the email with him real quick.
Sure.
And then I will grab Andrew.
I'm here.
All right. We're gonna pull you into a breakout room here in 1 second here, Joseph.
Okay.
All right.
Your typing is so fast.
I know.
Yeah, it's like 200 words an hour. It's like
It's still recording, by the way.
Thank you.